Well, hello everyone. As you can see, this is the last problem in the final exam study guide, and it is a rational equation. That is, it has fractions, and what makes this one so all-encompassing is that when we clear fractions, we're going to end up with a chapter 8 quadratic to solve. And so this is really the complete course problem. Now, I want to get after this, and what I did first here was, as is my style, is I stretched this out and gave myself room to work. And I also factored everything. So for instance, I took a 2 out of this quantity here to get 2 times the quantity x minus 2. And then I parenthesized the denominators because I'm preparing for canceling. And I created elongated fractions here because I'm going to need space to pluck in my factors that will do the canceling. Notice that this here has a factor of x that you can pull out, and that leaves behind 2x minus 3. So now we're ready to play the game of wouldn't it be nice, and I'll begin with this term here. Wouldn't it be nice if I had a 2x minus 3 here? Because if I did, I could cancel the 2x minus 3's, and lo and behold, the fraction would be gone. Well, because we have a equation, we certainly can make that so. Just all we have to be sure is that we multiply everything by 2x minus 3. And so that's what I'm doing here. Every term on both sides of the equation, take that multiplication. Now, the technique I'm showing you here builds the LCD as you go. And so this is part of the LCD, that factor right there. And then what makes my technique different is that I cancel midstream. And I think, I don't say this is a brainiac moment, but you got to wonder why no one else seems to have discovered this technique, because you see what happens is that we get by canceling midstream, we now know where we need to head next. And I see that really the only fraction that exists, this one and this one. And it would be certainly nice if I had an x here, because that would cancel here and it would cancel there. And so that's the next game. Wouldn't it be nice if I had an x here? And of course that means I have to multiply every term by that. And so make it so. And now I can complete my LCD because I know that when I multiply through by that combination right there, what happens is everything is going to cancel. And let me show you that. These x's are going to cancel, and voila, we no longer have a fraction over here. These x's are going to cancel, and the same is true on the left-hand side. So we no longer have any fractions, and the game becomes one of simply rewriting with all the cross-out items deleted. And of course, we no longer need to show fraction bars. And when we do that, we get this. So we have dramatically simplified this problem. We have cleared fractions, and now we're ready to distribute here. And of course, we're multiplying by -1 here, so that's going to be a sign changer. And the parentheses here aren't needed. So that's my next move. I would call it ridding myself of parentheses by doing the distributions. And notice what happens here. Notice that, well, first notice that the 2x went to -2x and the -3 went to +3. I don't want to slip here. There's a sign change going on here. And then of course, notice this is that this times this gave me 2x squared, and I don't have any other x squareds. So this x squared is going to be part of the problem, part of the equation, which puts us into chapter 8. We have a quadratic to solve. And the technique there was always to get everything on one side and 0 on the other. And so that's what I do is I subtract x from both sides, I add 3 to both sides, I combine like terms, and when I do that, I end up with this trinomial equal to 0. And so now, does this trinomial crack? And if it does, we're going to have two binomials with 2x here and x here, because that's the only way we can get the multiplication to go to 2x squared. And that's one of the trickier, harder trinomials to crack. If you didn't want to take that route on this one, well, you could solve this using the quadratic formula. I like to factor things if possible, so I played with it. And it took me 3 times before I got the right combination via trial and error. And this is how it cracked, like so. Notice that 2x times x does in fact give you 2x squared. And 2x times -2 gives you -4x. -4x here, and then -3x here. negative 4x and negative 3x will give us that negative 7x. And of course, the negative 3 times the negative 2 is positive 6. This was a really tricky one to crack because you would think you could factor 6 as 6 and 1, and it's very tempting to think that's the way home. When that doesn't work, you need to use 3 and 2, and you need to get them in the right places. So it took a lot of effort to get that done. You might want to try the quadratic formula on this. At any rate, I now know all I need to ask myself is what makes this linear factor 0 and what makes this linear factor 0. And there's only two possibilities there. They are 3/2 and 2. Now this is where I emphasize that you should always check your work, because this is a key insight here, in that when you take 3/2 up here and sub it in, what happens is that this thing goes to 0. And so we have to exclude that solution there. It's out of bounds. And so we delete that. And then of course we take our 2 up here and we try 2 everywhere. And it turns out that 2 is good and works. And so it does in fact check. I'm not going to belabor you with that. But so a very involved problem.